Right, in this video, we're going to talk about the half-range Fourier series. We have seen the full-range Fourier series based on this theorem. If f is a piecewise continuous function and 2L periodic, which means periodic with period 2L, then f can be represented by this series here of sines and cosines, which we've labeled 1. The an and the bn, called the Euler's coefficients, are defined by these formulas 2, 3, and 4. So that's the full range Fourier series. Now, if f of x defined over the interval minus L to L is even, okay, or its periodic extension is even. So sometime f of x may not be inherently periodic, but its periodic extension may be periodic. Then these formulas can be simplified. In particular, let's start with this one here. If f is even, we know that sine is odd. So the product of an even and odd function gives you an odd function. So this formula number 4 here is going to be a symmetric integral of an odd function. And so that's going to give us 0. But for this one, it's going to be an even function times an even function. So it's a symmetric integral. So it means we can actually evaluate it over 0 to L and then just multiply by 2. Same with that one. So that means formula number 1 is going to simplify because we are going to lose this term here. All of these are going to be 0. So f of x we can write as a naught over 2 plus, it's just going to be the cosine terms here. So cosine n pi x over L, and ranging from 1 to infinity. And the coefficients an will be 2 over L integral from 0 to L f of x cosine n pi x over L dx. And this type of series is called the half-range cosine series, okay, which is called the half-range cosine series. So that's for the case when f is odd. So remember, f is even. Remember, evenness and oddness has got to do with what happens across the origin. So that's why this is going to be from 0 to L. And here we are talking about the behavior of the function across the origin in this symmetric interval. So that's the half-range cosine series. The other side of this is if f of x or its periodic extension is odd. So in this case it was even. So we need to make sure this is defined over the period, the interval from minus L to L. This is odd. Then the reverse is going to happen. By reverse I mean this is going to be 0. That is going to be 0 because we've got an odd function times an even function. But this one is going to add. You're going to have odd times odd. Odd times odd is even, whereas odd times even is odd, and then even times even is even. So it's a bit like parity, you know. Plus times minus is minus. Minus times minus is plus. And then plus times plus times plus is plus as well. So even here, odd and odd times odd gives us an even function. So in this case, these terms are going to drop out, which is going to have that one. So so f of x is simply going to be the sine terms n pi x over L. Of course, for the sine terms, n equals to 0 doesn't count because sine 0 is 0. Where so the bn are going to be 2 over L integral from 0 to L f of x sine n pi x of that. Okay, and this one is the half range sine series, the half range sine series. All right, so before we do any examples, let's just make mention some conventions. So if a question says find a full range cosine series, then the interval given is always going to be taken to be 2L. Okay, so let's do an example here. The question says find the full range Fourier series of f of x. Suppose let's say f of x equals to x squared, and suppose the interval is given like this. Okay, then if the question is saying full range, then the implication is that 2L is equal to 2, which is this range here. Okay. However, if the same question now says find the half range sine or half range cosine series of this exact same function, x squared defined over 0 to 2, then in this case, because this is half range, then the implication is that 0 to 2 is half of the period. So that means L is going to be equal to 2 this time, because this is only half of the period. The other half is going to be the other side of the origin, which is going to be from -2 to 0. Okay, so that is going to be pretty important. Actually, we're going to see this as we work through some examples. So the same function can be expressed as a full range, but of course the periodic extension is going to be different, as you'll see. Full range series, or same can be expressed as a half range sine series, which means if it's half range sine series, automatically it's going to, the periodic extension is going to be odd. But if it's half range cosine series, then the periodic extension, what happens in the other half of the period, is going to be an even extension. But like I said, we are going to do an example where we are looking at exactly the same function. We expand it as a sine series, expand it as a cosine series, and then we expand it as a full range Fourier series. All right.